I'd like to introduce some work that Digerati are doing using IIIF and natural language processing techniques to drive improved description and discovery of digitized cultural heritage resources. So by way of background to this work, we could imagine a perfect world in which someone approaching digitized cultural heritage content would have rich and accurate descriptions for all of the objects in a collection. There would be good machine readable metadata for each of those objects, and that metadata would be created using open standards. The values in that metadata would use authority control where possible, and there would be linked open data with URIs for values where there were existing datasets that were relevant. All text would be fully and accurately transcribed, and this would mean that the end user browsing or discovering that content would have access to full text search, and they could browse by date, by topic, by person, by place, and the content could be placed on a map or viewed in a timeline. And all of these different ways into that content would drive serendipitous discovery, where the end user may not necessarily have to know that much about the content in order to find things that were of relevance to them. Now, the reality is that in most cases, the kind of metadata that can drive this rich discovery experience is usually only available at the level of the whole work. So you have information about the author of the work, date of the work, place of origin of the work, and so on, but not information about person's name within that work, dates described by the work, places covered by the work. And all of this metadata is labour intensive to create and requires specialist skills on the part of archivists, librarians, museum curators, and so on. Furthermore, in the real world, the very richest data would normally only exist for the treasures of a collection, and most objects would have sparse catalogue records. In particular, archives, personal papers, and modern manuscripts are often the poor relations. This would mean that discovery inside objects is impossible, or it's limited to free text search. So there's often no browse across that content, there's very little in the way of serendipitous discovery, and there's no placing of that content in timelines or on maps. And all of this hinders the non-specialist user. Now let's take as a case an instance where there is some information about the content inside an object, and where the full text of that object is available as annotations on the object. So, for example, if we open up an item from the Welcome collection, and we view that in Mirador, which is a IIIF viewer, we can see the images, and we can browse through these images, but we also have access to the full text that's been created through an OCR process, and we can bring that up as annotations. So we see there are line-by-line blue boxes that contain text, and if the end user mouses over these boxes or hovers over them, they can see a textual transcription. Now in each case, this is just raw text. It's a string of letters and numbers. There's no information contained within this, and no way of searching it or doing anything with it other than view it in the browser. Now let's take a slightly more involved user experience. So let's take the same object, but this time we're going to view it in a different IIIF viewer, in this case the universal viewer, and this will give us access to full text search across that OCR text. So in this case I've typed in the word Mendel, and I've found lots of different hits for that word through this volume. I've gone to one of the pages, and I can see the word Mendel highlighted on the page. So there is at least some way that I can begin to navigate inside the content of that object. But nonetheless, this is just pure text. I'm searching for strings of letters and numbers, and I can only find things that I know that I'm looking for in advance. Now, what if we were to try and bring software tools to bear on digitized cultural heritage objects and try and extract information about that object from its content? So potentially we'd have data about the content of the object, not just about the object itself. We might go some way to solving problems of scale. Crowdsourcing might work, but if there are hundreds of thousands or millions of images, that isn't going to work. And we can get semantic information. So not just strings of characters and numbers, but we get things like named entities, persons, places, dates, events. We may be able to auto-generate links to other data sources like Wikipedia or DBpedia or GeoNames and so on. And if we can get some of that information out, we can then create user interfaces that allow people to browse that content, view it in timelines or on maps, without labour-intensive specialist cataloguing, which may not be practical or affordable. So let's take a case where we have existing full text. So this would be a similar example from the Welcome collection that we looked at before, but this time we've taken that same content and we've applied some natural language processing techniques to that content. So this time I'm bringing up the same object in Mirador, the IIIF viewer, and I can bring up annotations and I can see the line-by-line text boxes. But I can also see now that within those boxes there are smaller units that have been highlighted. So we have individual words or individual phrases that have been picked up as names of people, for example. So we have Mendel here identified as a person. Or if we go to a later page, we can see that Greece is identified as a political entity, the Royal Society of London as an organisation, and Hook as a person. And this would let us drive discovery or index the material by people named within it, place it on maps and so on. So how does this work? Well, the IIIF Presentation API provides information that can include see also links, which link to machine-readable metadata, including in the case of this welcome object, OCR full text in Metsalto format. The code parses that IIIF manifest, discovers and then parses the Metsalto XML, runs natural language processing tools across that XML, and then generates new IIIF annotations on the same object that contain information about people, places, dates, political entities, and so on. So if we look here, we can see an excerpt from a IIIF manifest, and the highlighted block is a see also block that contains information about related resources in machine-readable formats, and we can see that this is text XML and that it's Metsalto. So the software can pick up on this, analyze it, and then generate those new annotations. However, what if there's no OCR full text? What if we're starting with an images first approach? So to take a case study, the Indigenous Digital Archive, a project that Digirati are working on, consists of over 200,000 images of archival records concerning the Native American community, mostly in New Mexico and other parts of the United States. And the first round of these archives will focus on records relating to land and to the federal boarding schools and day schools in the late 19th and early 20th century. This material has little or no archival description, and there's no machine-readable content that exists in advance. There's also no OCR full text, and yet people, places and dates are crucial for discovery and access to this content. So let's take, for example, one of the records from the Indigenous Digital Archive, and we'll view it in a IIIF viewer like Mirador. And in this case, we can see that there's lots of information contained within the page. There's place names, organization names, there are dates. But this information isn't accessible in a way that can drive a discovery experience, or which can be used for search or browse, or to do any kind of analysis of this information. Flicking forward to a later page within the document, we can see that individuals are named. There's the name of a school, and again, dates, agencies, organizations, and so on. Now, what if we take the same object and we process it through Digirati's toolset and then we try and view it again? So let's take exactly the same thing, and this time we bring up a IIIF annotation layer, and we can see this time that there are blue boxes highlighting this text, and these are annotations on the object, and there's now information about the date, that would let us place this content in a timeline or organise it by date. There's information about an organisation, in this case the San Juan Agency. Even quantities are identified. There's a geographic entity, a place name. And if we flick forward, we can see, for example, that the name of a school has been picked up. And if we flick forward again to one of the pages that contains personal names, we should see that the text analysis has picked up on the fact that there are names on the page. So we can zoom in here, for example, and we can see that there's a Dr. M.M. Carmichael. There's a place, Shiprock. And again, we have an agency name, we have a date, and so on. Flicking forward another page, exactly the same. We can see that the name of an individual has been picked up, Dr. John D. Kennedy, along with the same date information, organisation information, and so on. So, how does this work? Well, it works in much the same way. The code parses a IIIF manifest. That manifest contains information that gives the software a way of getting images from that content. It downloads a temporary copy of the image, it OCRs that image in a workflow that parallelizes the process so it can handle quite a high workload. It parses the OCR text, runs natural language processing tools, and then generates those new IIIF and W3C annotations that contain information about people, places, dates, and so on. And it can do all of this in near real time. So if we look here, we can see a manifest with the image API information highlighted. And there's a URI in here the software can use to go and fetch a high resolution version of that image in order to do OCR and then textual analysis. So what can we do with this image first approach? Well, we can do all the kind of things that you would do with a heavily curated, very manual process. We can drive faceted browsing. We can place content in timelines or on maps, even if it hasn't been catalogued. We can do deep dives into the content and not just sit at the level of whole item description. Potentially we can do automatic topic identification and subject classification. And any first pass analysis that we do can be refined and improved by specialists and then run again. So there can be a continual process of getting better and better at extracting information from the content. So what are the next steps, at least in the short term, with this kind of toolset? Well, the first things we'd like to do is improve the OCR training. And we'd also like to offer a choice of OCR engines. So some engines are better at historic fonts, for example. We'd like to do better things with segmenting. So that means content that's stored, for example, in tables or in newspapers. Better on-the-fly binarization, so we can handle color content. And then improved entity extraction by using custom taxonomies and gazetteers, so we can drill down into particular topic areas and improve accuracy where there's a specialist set of vocabularies or a specialist set of terms that may be in use. And we can integrate with sources of linked open data like GeoNames, DBpedia, and so on. I hope you can see this is a very promising approach, taking an images first approach to extracting semantic information and doing classification on digitized cultural heritage objects without requiring very heavy levels of in advance skilled cataloguing.